today mock assessment. An integer x is good if after rotating each integer digit individually by 180 degrees, we get a valid number that is different from x. Each digit must be rotated. We cannot choose to leave it alone. What does that even mean? Given an integer n, return a number of good integers in the range 1 to n. So n is up to the 10 to the power 4. So I guess I can just prove first. There are 4 good numbers in the range 1 to 10. 2, 5, 6, 9. Note that 1 and 10 are not good numbers. They remain unchanged after rotating. Okay. 0, 1, 8 rotate to themselves. 2 and 5 rotate to each other. So they become invalid. I can just go to rotate, I think. If x equals to 0, or x equals to 1, or x equals to 8, just return to itself. Else, if x equals 2, return 5. Else, if x equals 5, return 2. Else, if x is equal to 6, return 9. Else, if x equals to 9, return 6. And otherwise, just return -1. Zero, return answer here. Basically, I just do the proof first. 1. And try to rotate for all numbers. If is good, 9, then answer plus. Boolean is good, x here. So if the number is good, then it means that we get a valid number. So actually, well, I think there's a faster way to do it, but I don't know, because you must contain at least 2, 5, 6, 9. That's the first condition. You need to contain either one of these, and for the remaining, you can just choose anything, but you cannot choose 3. You cannot choose 4. Yeah, basically you cannot choose anything, any digit that after this rotation it will be invalid, but other than that you can choose anything. But I guess in this case we can prove first because of the constraint. Right, changed equals to First, returns is changed. So just do for every digit while x is greater than 0. Digit is x mod 10. If rotate, let's say r, if r equals to -1, you just return first, and if r is not equal to digit changed equals to true, and then we're going to look for the next digit, something like that. Okay, should be good enough. Yeah, let's try to run this. So the time complexity is going to be n log n. Because each time we iterate n times basically, then each time we will do this while loop, and this while loop costs log n time. And for space complexity, I don't think we use any space, so it's all 1. Okay, let's try another test case. It's 1, 2, so it is 4, 0, 1 in the result. 4, 0, 1, yeah, that's the result. Start submit. Accepted. Let's go to the next question. Okay, it seems more complicated. We are given an array representing a row of seats where seats I equals 1 represent a person sitting in the I seat, and seats I equals 0 represent that the seat is empty. There is at least one empty seat and at least one person sitting. Alex wants to sit in the seat such that the distance between him and the closest person to him is maximized. Okay, what if there are multiple answers? Okay, we're returning the result. You're actually returning, the distance. So what I'm thinking is we can use stack, or can we? It's just as you know what? We're just going to know what is the where is the next occupied, and where is the left occupied, and we can know iterate for each seat. Assume Alex is going to sit here. What is the distance? So in order to know the distance, we need to keep the record of left the left occupied, the closest left occupy, closest left occupy, and the closest right occupy. Yeah, for the closest left it's easy because it's going from 0 to I. When it is occupied, then it just updates its closest left. What if there's no empty seat? Okay, at least one seat is occupied. Okay, fair enough. So when Alex, for example, reaches this point, and I'm going to, this closest right is going to keep incrementing until it reaches the next occupied, which is 6th, and it stopped. And then Alex can go here, and it will know that the distance between this one and the distance between this one is going to take the minimum of that. So we want to know the maximum distance. So this is the maximum distance. So it's going to be 0. Let me go to here's length. We need to know the closest left. Equals to probably going to be -1 because we don't find it yet. Closest right is going to be -1 first, then do a first for loop. If seat I equal 1, then it means it is occupied. Then the closest right is going to be I and then break. Okay. And now this closest right should have something. Okay, fine, should fine. Okay. Well, maybe if closest right equals to -1, then while closest right is less than n, and seat the closest right hold on, here, not that, is equals to, if it is an empty seat, then it is not occupied. But in this case, we want to find the closest right that is occupied. So while this case here, closest right is going to be maybe plus. Well, how about that? If it is less than 9, then we need to keep incrementing. We need to keep incrementing. So while closest right is less than 9, and then closest right is less than n, and then it is not an occupied seat, then we need to keep incrementing until the seat is actually occupied. If sit I is equals to if sys I is hold on. If sys I is actually equal to 1, then it means the closest left is equal to I. Else it means that this is actually an empty state. So this left is going to be, well, this is equal to 0, and then if closest left is not equals to -1, it means that there's some occupied state on the left. So this is going to be math.max this. And then, yeah, we need to know so that one is like I minus closest left, and if closest right is not equal to -1, it means there's something on the right, so you have to consider that as well. So it's going to, so hold on, if it is not equal to n, actually I can put the variable in the for loop. Here. If it is not equal to n, then it means that there's something on the right. Can calculate that, and after that we can know, we can know the distance, the distance if we put Alex on the I sit. Okay, let's try to run, okay, sorry, let's try to dry run this. So this is state equal here, the closest right is equals to -1 in the beginning, the closest left is going to be -1 as well, and then so we're pointing at here for the closest right, because this is originally is -1, because it's less than 0, so it's keep incrementing, so it is still less or equal to 0, I guess. Less or equal to I, we still need to do. And then we put here. And then we put here, we just keep incrementing. And this is the closest right, which is 0, 1, 2, 3, 4, which is 4. And then closest left, we just do the first one, it's going to be here, and it stopped. And for the second one, the disk is going to be here. So the disk 1 minus 0 is 1. Oh, I actually need to put, I actually take the minimum. So this is going to be integer max value, because I want to take the minimum. So I take the minimum and I get 1. 1 is not good, and I go to here, and then I get the answer 2, I guess. Yeah, that probably should be good enough. So the time complexity is going to be when, although it seems like it's doing a nested for loop here, however, this one is actually 2-pointer. So this closest right, which is increment on its own, is nothing related to this increment loop. So it's more like n plus n. That's why it is not n squared. Hope that makes sense. So there's 2. Okay, let's try another test case. 0, 1. So it'd be 2, 3, 1. 2, 3, 1. Okay. Sure, submit. Okay. Seems like I passed. Let's finish. Alright. I guess that's pretty much all for today.